So I'd like to get started on the software portion of the video. And this is one of those things where I could talk a lot about this software. I want to not, one, make people fall asleep, but two, I don't want to make this an hour-long video just on software. So the point here is there's a lot of flexibility in this software. There's a whole section on heat maps, which I will probably make a second video on. This heat map is not anything that's required for the workflow, but it's nice to kind of present to colleagues with a visual representation of your work, and it's just not required. So I'm going to leave that for later on. It is also in the manual. But the use of the software is just kind of nice to get a video tutorial of. So this is the landing page, just started the software. I'm going to connect to the camera, multiple cameras here. So I'm going to hit OK. Then I am going to initialize the software. You can see the message pretty standard, pretty straightforward. I'm also going to go into the calibration of the system a little bit later. This is basically going to assume that it's already been calibrated and there's nothing off-putting about that, and I just don't want to spend a lot of time on the calibration. There is a full auto calibration. It's straightforward, easy to use. And there's some tricks on it, and I can spend a lot of time just on the calibration. So I'm going to kind of breeze over that and go right into it. So I'm all connected. I'm ready. You can see my sample list is empty. I don't have any image here to select any spots of interest. So the first thing I'm going to do is hit acquire. This is going to ask back or front. This is a two-position configuration, as I explained earlier. I'm going to hit OK. The other option while this is scanning is that you could browse to a previously scanned image. Again, this is one of those things where, you know, the user has to be properly informed on how this works, but the scanned image, the previously scanned image, you can't, you know, kind of move the slide once it's kind of calibrated, as you'll see here in a minute. You do run the risk of being off in pixel resolution. So you can see here, no mouse was harmed in the making of this video. So Mickey Mouse's cousin is perfect. We just drew a little heart on there, a little kidney, a little stomach. You know, just for demonstration purposes. But, you know, typical workflow, again, just like the manual, take it out of the freezer into the desiccant for 15 minutes, and then you're able to then put it on the system to do an extraction. So that step was skipped, and just for convenience, and we're going to not have to worry about any contrast or brightness here. It's a well-defined picture, so we're going to hit accept. Okay, now it reminds me to put the tray back into the correct position. Select OK. Now I choose my 2 calibration points on the tray that are well defined. And now I can select any spot on the mouse that I choose. In this case, I'm going to start off with the heart. I'm going to name this. This is the wizard that now populates the sample list. In this case, I've chose shift and left click, which on the heart, which then only allows you to select one point. If I want to select multiple points, which I'll show you in the future, it'll be a grid or some sort of pattern, and I can actually fill multiple spots in the sample list. In this case, it's just one. I'm going to go through a little bit of the settings here. Some of these are pretty self-explanatory, but the calculate vials or calculate samples per vial, the software can automatically calculate how many samples you can get out of a 2 ml vial if you tell it how many extractions that you want, injection volumes and sample volumes. It'll automatically calculate that. You don't have to use that feature, although it is somewhat helpful if your extraction solvent is limited. You can just use the first vial in the extraction solvent tray. The positioning for the laser, I say that the present Z position of the syringe tip is really just for standard LC. So this system can be used as a standard LC out of 2 ml vials or deep well plates. But in this case, we're going to use the second two options. We have laser and measure probe distance now, or laser probe distance in real time. And essentially, the real time is what I usually recommend. If you would imagine that you have your sample out for some time, you can sort of like get dried up, like just like dry skin, right? Where it's going to start, producing peaks and valleys, and the laser usually catches those pretty well. There are some other advanced features that you can do that we explain in the manual that will step around with the laser to get a average. But in this case, we just use the real time. That's the best, starting point for most people. The optimal probe to surface distance is, again, user variable. We recommend starting at 0.2. If you're using a more more of a solvent, a higher ratio of solvent in your extraction volume, it will affect your surface tension, so you do have to consider that, and some of this may need to be optimized. But for now, we'll go with the 0.2. And the number of extraction cycles, just as I mentioned in the manual extractions, we start off with 5. Injection after or inject after sampling is automatically chosen by default, but that can be deselected, and it will actually ask you if you want to inject. If you're using trypsin or something in your matrix, and you have to be careful about how much extraction solvent you're using, that can be an option. Manually confirm injection is basically just so you don't waste time. It's more of a babysitting step, but wasting time on the LCMS run if you didn't get a proper liquid micro extraction. But again, this is set up to be more of an automated feature. We just wanted to keep the flexibility there, so I do not usually check that. Select OK. It tells me that it's done. I now have a sample in my list with some of the variables that we previously discussed, but you can see there are some empty columns. Here's the sample method. If you right-click, which should be shown in blue, you can select the auto sampler method file, and here we have some predetermined sample that we know work. So we select that, and then we hit open. That populates that. We can adjust the sampling parameters by right-clicking again and hitting open sampling parameters. Again, this is not necessary, but you can see here it's quite a bit of sample volume and inject volume. I can change this to something smaller, something maybe more like 5 microliters. Inject the 5 microliters. Why you would want to inject more than what your extraction volume is which is in the next line right here. That's there's some playing around that you might have to do in the method development on this, but essentially if, for example, you're doing something more where your ratio of solvent to aqueous solution is, higher than what you would prefer to have in your starting condition of your run for your HPLC, then you can actually choose a bigger loop size for your sample loop, and it will essentially mix with your initial buffer run conditions so that you could get away with using a stronger solvent. But as I mentioned in the manual injection, we recommend people start off with 50-50 acetonitrile water with a 0.1% formic acid just to get some penetration to the tissue. Some of these are pretty straightforward. I'm going to knock these wash cycles down to shorten the run. We only have one wash here. In this case, it's wash 2. Injection valve is listed, and then we can save this, and it's saving the method parameters. It also asks if you want to update the HPLC time. The HPLC time is only necessary if you do not have contact closure set up with your LCMS. So if you have contact closure set up with your LCMS, the HPLC runtime is not necessary. If you do not want to configure it with the contact closure, you could put a timeline in the HPLC time that essentially will wait until the run is complete before going on to the next sample. In this case, I'm going to double click on this and just change that to 1. The MSD data file and the MS acquisition method file columns rather is really for heat maps and generation of exported sample lists, but in this case, in this example, we're not going to show that. All right, so I have all my methods here. I could actually now do a run, and I could watch this auto sampler move around, and you can kind of see it on this screen. I think I'm going to, at this stage, forgo that just so I can show you the alternative method to actually add a group or area of samples. So at first I did shift and left click, and that popped up a wizard. But if I actually hit control and drag the mouse over an area, I now get this new window. Very similar to the other one, the only difference being the top part has a fill area, a horizontal line, or a vertical line in conjunction with these parameters over here. In this stage, it's 1 millimeter fill area. So X and Y is going to go 1 millimeter. There'll be another sampling dot. So you can imagine at this large of an area down here, that could be quite a few samples. So I'm going to change that to 5, and I'm going to increment this by 1, and it actually will put a -001 at the end of this. So now it's going to be a different name than what I already have here in my sample list. So I'm going to leave that fill area, but you can imagine if I just selected horizontal line, it's only going to make one horizontal line. If I select a vertical line, it's going to make only one vertical line. So in this case, I'm just going to use the fill area so you can see. I'm going to leave all these other positions we previously talked about and just hit OK. Now you can see, just letting you know that it's done, but now you can see there's, these 5, let's see, well, a lot more than 5. It's more like 12 other samples here in this grid pattern that I want. But let's say I wanted to get rid of these, some of these, because as you can see, this one right here, this yellow dot, or this yellow cross is outside of our mouse tissue. So I can Alt and then left click and drag, and it says, do you want to remove this spot? I hit yes, and you can see my sample list is now updated here, and the dot or the cross is now removed. So I could do that and repeat that if I would like on other ones. The other way is to highlight one, and you can see it changed it to blue. I can right click and hit clear and do selected row, and it will remove that as well. And you can see that it removed it, the dot from the tissue, and yeah, everything is kind of happy. So at this point, I'm just going to delete several of these so that we can get back to running just the one sample here. So again, very flexible. These extraction numbers can all be adjusted on the fly as far as things that haven't been run yet. We do not have a run queue per se. So if your system is running, you cannot add samples on the fly. But as far as flexibility of the parameters that you have here and the ability to extract multiple points is there. The other option that you can do is if you, for example, want to turn your injection off, it will actually collect multiple spots in multiple areas of the tissue, and then the last sample in the sample list you can make inject yes, and it will actually inject that. So you can sort of get an accumulation of different areas of tissue into your injection results. So now that I have this done, I want to just do a quick check. I mean, in our daily workflow, we say, you know, the first sample of the day, just do a, laser distance now and an actual go to syringe position so that you can get a little bit of an idea of where you're going. It's not required, it's just a recommendation. So the other way to do that is right click on the sample that's highlighted and do a pre-check that way. So you could go laser measure distance now, it will move over, and you can't see the laser at this point, and it's not focused on the laser, but it is moving. It went over. It tells you, hey, do you want to change this position? You could hit yes, then done, and then I could verify that by doing another pre-check and actually go to the stored position that I just checked. The needle guide locking message that you just saw is basically so that when the as this is moving, I'll explain it, but it's essentially is, you could imagine if you had a micro junction with the lower needle guide down in the down position, you potentially could run the risk of wicking up that extraction solvent onto the lower needle guide, and that's obviously not good. So the other part is you really want to be able to get a nice quality assurance of, is my droplet actually going on tissue? So this is where you get an idea of where this is. So I can see my position's not exactly where I chose on my screen. If I reference here to here, it's a little bit off. That's probably due to the bad calibration that I need to do a little bit better on. But at least this gives us an option, that we can adjust this. It says you can adjust it manually. Say okay. I choose my step size, but basically this is just left and right, moving this around. I then move this to a position where I'm happy. It's quite a bit off there, and down. And once I'm happy with this, I can actually, I think I went a little bit too far down there. And accept. and my system comes back to ready, and now I can continue with my run. I'm just going to start a run just as an example of how this looks in this little live camera. I'm gonna kind of shrink this video down just so I'm not wasting your all's time, but essentially this will allow us to look at a nice microjunction and see what this looks like. Here's the droplet. And then it sucks back in. So that was intentionally more than I like to put down on tissue. At least, when you're doing method development, it's fine. But, when you're optimizing a run, it's probably not going to be that much. We've done anywhere from 700 micron spatial resolution, but typical is probably around 1.1 millimeters. I have had Dr. Vilmos Cortez do some experiments. He's the I guess the founder, original developer of this product, and Oak Ridge. He's from Oak Ridge National Laboratories, and he's done work in the 3 to 400 micron range.